homogeneous mixtures, solutions, solvent, the component present in greatest amount, solutes, all other components, aqueous solutions. Water is the solvent and either a gas, liquid, or solid as a solute. The ability for substances to form solutions depends on 1. The natural tendency of substances to mix and spread into larger volumes when no restraint in some way. 2. The types of intermolecular interactions involved in the solution process. Three kinds of intermolecular reactions. 1. Solute-solute. 2. Solvent-solvent. 3. Solvent-solute, solvent-solvent. Interactions between solute particles must be overcome in order to disperse the solute particles through the solvent. Solvent-solvent. Interactions between solvent particles must be overcome to make room for the solute particles in the solvent. Solvent-solute. Interactions between solvent and solute particles occur as the particles mix. Heat of solution HSOLN. HSOLN equals H solute H solvent HMIX. We can consider the solution process as having three components, each with an associated enthalpy change. Solute particles separate from one another. Solvent particles separate from one another, and solute and solvent particles mix. Entropy of solution SSOLN. Crystallization. As a solute begins to dissolve in a solvent, the concentration of solute particles in solution increases, increasing the chances that some solute particles will collide with the surface of the solid and reattach. Saturated. A solution that is in equilibrium with undissolved solute. Solubility. The amount of solute needed to form a saturated solution in a given quantity of solvent, asterisk the solubility of a given solute in a given solvent is the maximum amount of the solute that can dissolve in a given amount of the solvent at a specified temperature, given that excess solute is unsaturated. Solution that is less dissolved solute than the amount needed to form a saturated solution. Supersaturated. Solution that contains a greater amount of solute than needed to form a saturated solution. Factors affecting solubility. Solute-solvent interactions, pressure effects, temperature effects. Solute-solvent interactions. miscible, pairs of liquids that mix in all proportions. Immiscible, pairs of liquids that do not dissolve in one another. Pressure effects. Henry's law. Relationship between pressure and gas solubility is expressed by Sg equals kpg. Sg solubility of the gas in the solvent, Pg partial pressure of the gas over the solution, K proportionality constant, known as Henry's law constant. Temperature effects. Asterisk. The solubility of most solid solutes in water increases as the solution temperature increases. Asterisk. The solubility of gases in water decreases with increasing temperature. Asterisk. Real-life application. Warming tap water. If you warm a glass of cold tap water, you can see bubbles on the inside of the glass because some of the dissolved air comes out of the solution. Molarity. Defined as hash of moles of solute per liter of solution volume. Advantages. Asterisk. Using moles of solute allows molarity to be related to the mole ratios in chemical arithmetic. Asterisk. Volumes of solutions are easier to measure and dispense than masses. Disadvantages. Asterisk. Solution volume expands or contracts with changes in solution temperature, so molarity changes slightly with changes in solution temperature. Molality. Defined as hash moles solute per kilogram of solvent. Advantages. Asterisk. Retain mole unit for solute. Asterisk. Does not change with change in solution temperature. Mole fraction. Defined as moles of solution component, total moles. Applications. Asterisk. Dalton's law of partial pressures. Gases produce pressure in proportion to the number of molecules present, regardless of phase identity. So in a solution of gases, the moles of each is the easiest way to express this. Asterisk. Raoult's law governs the quantitative basis of separation of mixtures of volatile liquids by the process of distillation. weight percent. Defined as grams solute per 100 grams of solution, weight percent equals mass of one component, total mass of all component x 100. Application: for food and industrial mixtures, where there are fairly large amounts of each ingredient, this unit is appropriate. Parts per million. Defined as grams of solute per million grams of solution, parts per million equals mass of one component, total mass of all component x 10. Parts per billion. Defined as grams solute per billion grams of solution, parts per billion equals mass of one component, total mass of all component x 10. Application: for environmental reporting of trace contaminants and legal limits on toxics allowable in air, water and food, ppm and ppbr. Colligative properties. A physical property of a solution that depends on the concentration of solute particles present, regardless of the nature of the solute. Properties include vapor pressure lowering, freezing point lowering, boiling point elevation, and osmotic pressure. Non-volatile versus volatile. No measurable vapor pressure versus one that exhibits vapor pressure. Vapor pressure lowering. Boiling point elevation. A direct result of a lowered vapor pressure is a higher temperature needed for a solution's vapor pressure to rise to external pressure. Tb equals Im/Kb, I Van't Hoff factor, M molality, Kb. Molar boiling point elevation constant. Freezing point depression. Because the triple point temperature of the solution is lower than that of the pure liquid, the freezing point of the solution is lower than that of the pure liquid. Tf equals Im/Kf, I Van't Hoff factor, M molality, Kf molal freezing point depression constant. Application: salting of icy roads to lower the melting point of ice. Osmosis. Net passage of solvent from a less concentrated solution or pure solvent to a more concentrated solution. When net solvent flow ceases, the solutions on either side are said to be isotonic. Osmotic pressure. External pressure needing to be applied to the more concentrated side of the membrane to prevent osmosis, equals IMRT. Reverse osmosis. Process of applying more pressure to the concentrated side, forcing solvent from the concentrated side to a less concentrated or pure solvent side.